Hi everyone, it's Math with AUB, another elegant frame just embarking upon the condition of tangency of circle, ellipse, hyperbola and parabola in a single frame. When the line touches circle, what is its condition? Line touches circle, ellipse, parabola, hyperbola in a single frame. Our question number 1 reads as, if the line y is equal to x plus c over 2 is tangent to the ellipse, condition of tangency of ellipse. Condition of tangency for ellipse, that is c is equal to positive negative a square times m square plus b square. In case of ellipse, that is our equation. But don't forget, it is valid for such type of standard equation, means when the major axis along x-axis, when major axis along x-axis. If major axis along y-axis, then we have to interchange a square b square. It is a matter of letter frame. In the second frame, I will discuss all these. It is a normal routine case. X square plus a square y square plus b square is equal to 1. This is the condition for tangency of the line y is equal to mx plus c to the ellipse in that form. When major axis along x-axis, when major axis along x-axis, when major axis along x-axis. Write the line. C is y-intercept of the line. A square, semi-major axis square, semi-major axis square. M, slope of line. B square minor x, B square minor axis square. That is the reality. C, the y-intercept of the line. MC belongs to straight line, AB belongs to ellipse. MC belongs to straight line, AB belongs to ellipse. I have written the information of all these. Just take the equation, that is our y is equal to x plus c over 2. On comparison, we have m is equal to 1, and in that case c is equal to c over 2. Our y-intercept is equal to c over 2. Okay, and here ellipse is x square over 16. It is already in the standard form. Y square is equal to 9. That's what. That's our a square. A square is equal to 16, while b square is equal to 9. Just utilize this value in the condition of tangency. You have required result of c. Or c is equal to c over 2. Or y-intercept is equal to c over 2. Plus minus times a square. A square means 16. M slope of the line. M is 1 square plus b. That's b is 9. B square is 9. So c over 2, positive negative times square root 16 plus 9. 16 plus 9, 25. So we have c over 2 is equal to plus minus times 5. C is equal to plus minus 10. C is equal to plus minus 10. Plus minus shows that from a single external point, two tangents are possible. First with positive one, second with negative one. Condition of tangency of line to ellipse. Ellipse in that is standard form. When major axis along x-axis. When major axis along x-axis. When major axis along x-axis. Okay, that's our question is. Our option is C, plus minus times 10. Okay. Moving to question number 2, we have given a line 2x plus 3y is equal to P. 2x plus 3y is equal to P. It is tangent to the parabola. Look at the parabola. Parabola is also in the most standard form, that is y square is equal to 12x. The condition for such type of parabola is C is equal to A over M. While if that is the case, then condition of tangency changes. If that is the case, then this condition of tangency changes. If y square is the major axis in ellipse, the condition of tangency changes, as well as if the transverse axis along x-axis or y-axis, the condition of tangency changes in both the cases. We are discussing normal cases. Positive x, major axis along x-axis, that is the routine parabola y square is equal to 4x. That is the routine hyperbola transverse axis along x-axis. So moving to once again our main question, y square is equal to 12x. In that form of parabola, Condition for tangency is C is equal to A over M, where C is y-intercept of the line, M slope of the line, A 25% of the length of latex rectum or 1/4 of the length of latex rectum. 25% of the length of latex rectum or 1/4 of the length of latex rectum. From this, we can easily manage the value of A. 4A is equal to 12. From this, A is equal to 3. Okay, what is the given line? That's our 2x plus 3y is equal to P. Put the line in that form, y is equal to mx plus c. Make the coefficient of y positive 1. 3y is equal to minus 2x plus p, or y is minus 2 over 3x plus p over 3. So in that case, m is minus 2 over 3 and c is equal to p over 3. And c is equal to p over 3. That's the value of m, that's the value of c, and we have already managed the value of a. Put all these things here, we are going to get the value of c. C is plus minus a. Positive negative shows that two tangents are possible, a over m, a over m. What is the value of c? C is r p over 3. C is r p over 3. A, value of a is 3, or m is minus 2 upon 3. It will become p over 3 is equal minus 9 over 2. 9 over 2. Shift 3 there, RP is going to be minus 27 over 2. Minus 27 over 2. Minus 27 over 2. That is the condition for parabola. 27 over 2, positive or negative. Okay, let me manage this one. P is equal to minus 27 over 2. Again, let me give a good overview. Y square is equal to 4x. We have taken this equation. For this, the condition for tangency is C is equal to A over M. We are discussing this condition. If that is the case, condition of tangency changes. Condition of tangency changes. Okay, moving to another question. When circle touches the line, there is no variation. There is no concept of major or minor axis or change of focus or direction in the case of circle. That is not the case. So we have circle is, our line is y is equal to 2x plus L, and our circle is x square plus y square is equal to 9. Okay. Condition for tangency of circle is C is equal to plus minus R times root 1 plus m square. 1 plus m square. I have already told you what is C. Condition of tangency of line to circle. C, y-intercept of the line. M, slope of the line. Only R belongs to circle. So let me manage this circle from this. It is the standard equation of circle. Having center at origin, x square, y square instead of 9, let me write 3 square. On comparison, R is equal to 3. R is equal to 3. Here, M is equal to 2 and C is equal to L. Putting these values, C means L, plus minus R means 3. 1 plus m means 2 square. So L is equal to plus minus times 3. 1 square of 2 is 4. So required value of L is 3 times under root 5 or square root of 5. That is the value of L when this line touches the circle. In case of circle, there is no variation. It will remain, the condition remains same. The condition remains same. That is the single case for only circle. For parabola, ellipse, hyperbola, major, minor axis, transverse axis, or square in y or x changes the condition of tangency. Okay, moving to final question. Moving to final question. When the line 2x plus c, 2x plus c, 2x plus c touches the hyperbola, y is equal to 2x plus c touches hyperbola, x square over 4 minus y square over 2 is equal to 1. On the outset, let me explicitly explain to you that is the condition for this. A square times m square minus b square. That is the case when transverse axis along x-axis. When transverse axis along x-axis. When transverse axis along x-axis. If transverse axis along y-axis, the condition for tangency changes. The condition for tangency changes. The condition for tangency changes. It will be discussed in the upcoming frame. Okay. In that case, m is equal to 2, our c is c. So that is value of our a square, transverse axis square, and that is conjugate axis square. Put here, c means c, plus minus time a square means 4, m is 2 square minus b square is 2. So c is equal to plus minus 4 times 4 minus 2. C is equal to plus minus 16 minus 2. So C is equal to plus minus square root of 14, square root of 14, square root of 14, or 14 is our answer in that case. Okay, let me give you another good overview or good overview recall for all these conditions. Condition of tangency for circle, ellipse, hyperbola and parabola within a minute. Let's see and find out how. Circle, no variation, C is equal to plus minus R times 1 plus M square. For circle, condition of tangency when line touches circle. C, y-intercept of the line. M, slope of the line. R only belongs to radius. R only belongs to radius. If that is the equation, if equation is in that form 4ax, then condition for tangency for parabola is to be C is equal to A over M. For such type of equation, square in y, that's the condition for tangency. If you square in x, something changes. Most there would change in that case. Okay, that's for parabola. Ellipse, when major axis is along x-axis, that we have discussed, that's the condition for tangency when major axis is along x-axis. When major axis is along x-axis, that is the condition, that is the equation of ellipse. Y square plus b square is equal to 1. That is the condition for tangency for such type of equation when major axis is along x-axis, major axis is along x-axis, and the line remains same. Y is equal to mx plus c. Eventually, for hyperbola, when transverse axis along x-axis, that is the case. X square over a square minus y square over b square is equal to 1. So for condition for tangency for hyperbola, c is plus minus a square times m square minus b square. Mark my words, when square in x, condition of tangency changes. That is not the condition of tangency for a parabola then. If major axis along y-axis, then this condition changes. If transverse axis along y-axis, in that case it is along x-axis, that is the condition. If transverse axis along y-axis, then this condition changes. This condition changes. It will be discussed in the upcoming film. It's my tiny effort for you to give you a good overview of the some good questions for condition of tangency of parabola, apple, circle, ellipse in a single shot. It's all by itself. Next.